Alright, so my talk is over a framework Andy and I use in iOS called Texture, and I'm going to go really briefly over what it is, why we use it, and how it helps solve problems, and hopefully that'll all happen in 5 minutes. Boom. Alright, so Texture, it is a user interface framework. Originally it was built for high performance on iOS devices. If you remember Facebook Paper from a few years ago, that's what it was originally made for. An engineer that started at Apple eventually went over to Facebook, and when designers came to him with all of these crazy animations that he knew really weren't possible to do within Apple's native frameworks, he knew that there was an opportunity there to make something that could allow for those much more easily, and that's where Texture, formerly known as Async Display Kit, came from. But since then it's grown to do more than that, and it solves a lot of common iOS development problems, which I will touch on in a little bit. So for Buffer, what problems does it solve for us? Mainly, it solves problems of performance when scrolling through content, like through your queue, most commonly. Interactions and touches whenever you go to do something within the app, and when fetching content, most namely, again, for your queue. So that is the what, and the majority of the talk will be the why we need something like this. So UIKit is Apple's main framework for creating any kind of user interface on iOS. And back in the day when this was being developed in 2007, right, that there was no notion of multi-core phones. Everything was single core. The notion of a mobile SDK was super, super new. Really, no one was even doing it at that point. But still today, over 10 years later, if you go look at the documentations, you'll see that there's this warning front and center that UIKit is a single-threaded framework and you can't do things basically concurrently. If it has to do with your user interface, it has to happen on the main queue, which is a problem. And you might be thinking iPhones have gotten several orders of magnitude faster, better, and stronger, and that's true, but it doesn't really matter because UIKit always only utilizes one core. So no matter how much faster the phones get, your user interface has the same problems that the first iPhone still had. And if an app is slow, even worse, there could be tons and tons of CPU still available to be used and processed. But since we're bound to that one core, they're just chilling out, having a good time watching the main thread hang. And again, each frame that's drawn on an iOS device always happens on the main queue. So we've got these kinds of problems that we started with on a single core phone, and we have several cores to use, but UIKit can't use them. So what do we want? We want each of our apps, Reply, Buffer, and whatever else magic we hook up, to always have 60 frames per second. So if you play a lot of video games like me, it's the same thing. Everything is super smooth. Every time you're looking at a device, it's rendering frames several times per second, and however fast or slow that is makes it feel responsive. Same goes for feedback. When you touch on something, you want 50 milliseconds tops for delay. Otherwise, you start getting into the chuggy feeling, and it's not feeling responsive. You don't know if it's frozen, and that's not what you want. So anything exceeds that will drop the frames, and you'll see a visible chug in the user interface that you don't have to look to see it, you'll actually see it stutter. And that's bad. I always use this emoji because it looks like Jansen in every single talk I have, so that's Jansen saying we don't want this. So how do we achieve that? So 60 times a second, right? We want to push a frame to the user interface. And if you think of that divided up, think of 1 second, and these are each milliseconds, and each one of those milliseconds we want to push up a frame. But if you divide that down, let's focus in on just 1 millisecond here. To push this frame, we have the front half of it to handle events. So this is pretty easy to optimize for, and we don't have to worry about it too much. With caching strategies and different queues, we can handle those types of problems. But when you get into the brunt of the work, like image decoding, text rendering, basically everything that Buffer does with a social network kind of app, those are very, very resource-intensive things to do. So the problem is when you go back up here and you try to do all of this work and maintain 60 frames per second, if just one of those frames starts to chug a little bit, it goes over into the next drawing cycle, and it doesn't jiggle, I guess. I don't know. That's when you drop frames. And when that happens, you see the visible chug, and no one likes it, and there's right? And so this was very hard to solve before we started using Texture, because as you can imagine, we have a long queue. Who knows how long people's updates are going to be, how many images they're going to have. I think about the best that we were doing was about 55 frames per second. When we really, and that's heavy optimization on our end, right? Doing a lot of caching on our end, remembering how tall or small an update is, things like that. So basically we have 16 milliseconds to do any layout work on iOS, and with system overhead that usually gets bogged down to about 10 milliseconds, which is not long. And when you look at our layout hierarchy, you can see that it's extremely complicated. Again, all of the things that are hard to do and resource intensive, we are doing actually like every single one. Download, image decoding, text rendering, all of those things. And each one of these is their own individual components. It's kind of blurred, but like this is its own thing, this is its own thing, so on and so forth. So Buffer had this problem, and Texture was the perfect use case for it. And when you talk about like how you can actually make a user interface in iOS, you have like two basic routes you can go. But they both have some drawbacks. The first is called manual layout, right? And it's just like a coordinate-based system. So you can say, I want in a rectangular region something to be an XY coordinate and its size should be 300 by 300. And this is really great, but it has a lot of drawbacks. And one of them is it's a lot of code to write this. Like this is just abbreviated, but when you see this function cgrect make like 50 times, your eyes start to bleed and it just gets really draining. It's very error prone too, so there's a lot of mathematics involved here, and if you divide by 0, you crash. If you get like not a number results, you crash, so there's a lot of ways to crash. And it's still bound to the main queue. So if you look at the other end, these are all the reasons why it's terrible that I just said. If you look at the other end of the spectrum, there's something called auto layout, and auto layout is really great, and it covers almost all of your bases for your layouts, but it's also extremely slow. And the reason that it can be slow is that it uses something called Cassaway's or Cassawary's algorithm. I always mix it up, so I just said both of them. And with it, you describe relationships. So you don't say something should be at 0, 0. You should say this view should be at the top of this other view. And while you can use hard-coded values, you're not really putting coordinates to anything. You're just describing relationships to how your view should be laid out. So that way, when the phone turns, it has this set of relationship and rules, and then it follows those to lay it out. But the problem with that is this algorithm is run at runtime, right? So that's why it's very slow. I don't have my notes, so I don't know what's happening next. Okay. So the performance hit is huge. There's this thing called storyboards where you can lay out your user interface using auto layout. But then that's a problem because you can have bugs that aren't even in code. They're just in this XML file, this arbitrary thing that you can use as a WYSIWYG editor. And it's still chilling out on the main thread. So why can't Andy and I just solve these issues ourselves? Well, the reason is the SDKs that we're using, they're closed off, right? UIKit is not something that's open source. We can't just go in there and make it better and try and solve those problems. We can use something called categories in iOS, which is basically a way to extend a class without actually subclassing it, but diminishing returns there. And to kind of make the problem worse, these new APIs that come out that maybe do solve some of these problems a lot better, we can't use for probably 2 years because we support iOS versions, one version back. So iOS 11 now, iOS 10. So all the cool stuff that got announced then, we can't use it. So how? I'm almost done. Basically, Texture uses the same, Texture uses the same thing that UIKit used to lay out things on the screen. So there's something called core animation. Everything that you see on an iOS screen is a layer. Then to make UIKit, they built a view to house layers to handle touch events. And in the same way, Texture uses nodes to describe a view or a layer. And they're thread safe, so now we can put all of this work to lay out stuff and download images and do text rendering. We can use concurrency. So all the cores that we have now are available to do all of this stuff. And even better, to lay out things, we don't use manual layout or auto layout. We use something called AS layout specs, which are hierarchical in nature. So we can just describe things, and it builds up this tree of a layout. Also, it can be concurrent. Also, it's built with Objective-C++. A lot of technical mumbo jumbo there. It's just faster, and it has things called layout ranges, so we can describe like when we should be loading in content. So when someone scrolls down, you should hardly ever see a spinner in Buffer because we're grabbing that content ahead of time. So it's just like scrolling forever. So if you go to like the Instagram grid preview, you can see this very obviously. If you start scrolling down fast, we should be fetching the content as you're scrolling, so you don't even notice that you've reached the end of anything. And that's kind of how that works. That is the how, and here's the very end. On the left is old Buffer, on the right is with Texture. And you can see